Welcome to my video on finding the equivalent resistance for two resistors in parallel. So the situation we have here is we have a current coming into a branch of a circuit, current I. Now the current I is going to be broken up into part of it goes this way, part of it goes this way. We have two resistors, R1 and R2. We don't know what those are exactly, but the current is going to divide up in the lower branch there, depending on the resistance of R2, and part of the current is going to go this way in the upper branch, depending on the value of R1. The greater the resistance, the lower the current in that branch. And then the currents are going to merge together and come back out as I. So the question becomes, and we know the voltage across this branch is just going to be V because we're treating those as an equivalent resistor. So it's going to be the same because they're tied together at these points right here. So the question becomes, what is the equivalent resistance of those two resistors when they are put in parallel? And that's what we want to find out. So one thing we do know for sure is we can use Ohm's law. And I've got a video on that if you need to get a brush up on Ohm's law. But we know that V, this voltage across both of the resistors, is just I1 R1. And V is also equal to I2 R2, but V is also equal to the equivalent resistance and the total current. Now we know this total current is made up of I1 plus I2. And so what we can do is if we can put these Ohm's law equations, we're going to put these equations right here into this. So what we're going to see is that, so if we solve for I, so V divided by R equivalent is equal to V divided by R1 plus V divided by R2. Now we notice that the V's will just drop out. So what we're going to be left with is 1 over R equivalent is equal to 1 over R1 plus 1 over R2. So that's the result we were looking for. One thing we're going to do next is we're going to change this because that is a sum of fractions. It becomes a little cumbersome sometime with math. So what we're going to do is we're going to do a little math. We're going to do some algebra next and simplify this. So if we start with the equation 1 over R equivalent is equal to 1 over R1 plus 1 over R2. Now the first thing we can do is we can multiply by R1 over R2, both equations. So we get R1, R2 over R equivalent is equal to R1, R2 over R1 plus R1, R2 over R2. Now we see that the R1 and R1 cancels out there, the R2 and R2 cancels out here. So what we're left with is R1, R2 divided by R equivalent is equal to R2 plus R1 plus R2. Now we're going to just cross multiply to get rid of, put the things in a little more convenient form. Now this R1 over R2 is just equivalent to, it's over 1 because everything really is over 1. So what we're going to do is we're going to do this cross multiplication first and then this cross multiplication. Now when we cross multiply, we're going to get R1, R2 times 1. Now doing the second cross multiplication, we get R equivalent times R1 plus R2. Now, if we want to get this in a little simpler form, solving for R equivalent, we're just going to multiply over 1 plus R1 plus R2, or R1 plus R2. We're dividing both sides of the equation, so we get R1, R2 divided by R1 plus R2. So we get R equivalent is equal to R1, R2 divided by the sum of R1, R2. So there's a simplified formula for calculating the equivalent resistance for two resistors in parallel. So next, let's do an example. So in this example, we've got two resistors. R1 is just going to be 22K, and then we have a 33K ohm, 33,000 ohms, and the current coming into this parallel combination of resistors. Now we know R equivalent is equal to R1, R2 over R1 plus R2. So R equivalent is going to be R1 is 22,000 ohms times 33,000 ohms divided by the sum of 22,000 plus 33,000. Doing the math on our calculator, doing the numerator, we're going to get 72660, so that's 726 million. And then we know when we add 22 plus 33,000, we get 55,000. Doing the math on our calculator again, we're going to get 13,200 ohms. That's R equivalent. So R equivalent now is 13.2 K ohms. And we can always check when we have two resistors in parallel, the equivalent resistance is always less. So the 13.2K is less than the smallest resistor in the circuit. Well, I hope you got something out of this video, learned a little bit about two resistors in parallel. If you did, give me a like, thumbs up, subscribe to my channel, and thank you for watching.